And now we're looking back to see how we solved those last two problems there in number 6 and 7. And it says, compare the strategies you used to find the volume in the two previous problems. How were they the same? How were they the different? In both prisms, I labeled the length, the width, and the height. Now the difference, I actually provided two differences that you could talk about, and there's certainly more differences. The difference was that in number 7, I used the volume as big B times H instead of the length times width times height. But I do understand we could do length times width times height in both. Another difference you could discuss would be the fact that number 7 was much easier to count the lengths of each sides, whereas number 6 was a little bit trickier, and you really have to be much more careful when you're counting that. So either of those answers would work, or I'm sure you may be able to come up with another a couple possibilities. Number 10. What pattern do you notice about the relationship between the side length of the smaller squares and the number of squares that will fit in the one each square? This is something that I just talked about in our last question. When we split it into thirds, we have 3 boxes by 3 boxes. When we split it into fourths, we had 4 by 4. So when we split it into fifths, we had 5 by 5. So use the pattern to explain how many squares with a side length 1/6 inch would fit into 1 square inch. So 1/6 of an inch tells us that we are going to need 6 inches going up and down for our height, and for our base we are going to also need 6. So let's see what I wrote here. The square will be 6 squares wide and 6 squares tall. I knew this by looking at the denominator, so I pointed out how I figured out this pattern, and then I did finish it off by answering it. There will be 36 squares, 36 1/6 inch squares to make up our 1 inch by 1 inch square. Next, for number 11, we need to find the volume of this rectangular prism. We need to remember to include a unit. Write a number sentence to show how you found the volume. Use the following formulas to help you. So since we have our 3 dimensions listed, it just kind of makes sense to use our volume equals length times width times height, which will be 5 times 3 times 6. When you multiply those out, we get 90. Do not forget our units, which is meters. Since it's volume, V3, or since it's 3D, we need to make sure that it's not just 90 meters, but 90 meters cubed, or to the 3rd power. Number 12, find the volume of the rectangular prism. Remember to include a unit. Write a number sentence to show how you found the volume. Use the following formulas to help you. Again, length times width times height, or big B times H. Now here they only give us 2 numbers, and you can see that this looks like it's reported in area because we know the area has a little 2 and they shaded in the bottom. So this looks like a perfect match to use volume equals big B times H, or the area of the base times our height. Since the area of our base is 8 feet squared, we are multiplying that by 7 feet. 8 times 7 is 56 feet. Now be careful with the label. A lot of students will want to put squared, but we are finding volume. So when we find volume, every volume answer must be reported with a 3, not a 2. That is a common mistake made. Okay, so please remember when we're dealing with volume, our answer must have that 3, V3, or it's a 3D shape. When they did the big B down here in the shaded part, they just multiplied 2 of the numbers together. So they probably multiplied maybe 2 times 4 to get that 8. So again, though, our final answer is 56 feet cubed.